Hi, and welcome to the first statistics lecture. I'm David, and I'm a PhD student at the Division of Pharmacoepidemiology and Clinical Pharmacology. Over the next couple of lectures, I'll try to teach you about statistics and how we can use it. Over the 4 lectures that we have in statistics, we'll go through a couple of topics. The first lecture, which is this one, will go through the introduction as well as the descriptives. In the second one, we'll go through how to visualize the data, as well as the distributions. In the third lecture, we'll go through the hypothesis testing, and the final lecture, we'll go through the correlation, sample size, power calculations, confidence intervals, and p-values. In these statistic lectures that we have, and also assignments and exercises, I'll try to keep the statistics very simple so that everything should be able to be calculated with a very simple calculator or by hand. Other than that, there are a lot of softwares for statistics out there, and some of those you can see on the screen here. I will give a software tutorial on one of the softwares at some point, so look forward to that. Some of the examples of the softwares is, so first of all, Microsoft Excel. It's been used for many years now, I think, and it can do like simple things as long as you don't have too much data, then it can handle it. Then we have R, which is a programming language as such, and you have to code a little bit when you're writing the different statistics and use different functions. Finally, we have Python. So Python you can use via Google Colab, which is free and on the browser. Otherwise, you'll have to install different displays for Python, which is also possible with the Anaconda, for example. Similarly, with all the different statistics software we have out there, they can all do the same basic things, and there are multiple packages for the softwares that you can load into the software so that you get more functions. Speaking about assignments, there are a series of practical exercises which are made to cover all the statistics topics in this course. So if you look on Teams, you should be able to find the assignments under the statistic folder. And it's essential that you try to complete these exercises before the seminar classes. So we have 2 seminar classes. The first one, statistics seminar in quiz 3, and the second one, statistics and measures seminar, quiz 4. So you'll make the most out of these classes if you complete the assignments before then. In addition to that, if you complete the assignments or have any questions to the assignments, these seminars are also optimal point to ask those questions. You can also write an email to me or post the questions on Teams for everybody to see. So now we have covered a bit of the practicalities in this statistics course, or statistics part of the course. So we'll now move on to statistics introduction. So what is statistics? According to American Statistical Association, statistics is the science of learning from data and of measuring, controlling, and communicating uncertainty. And this in particular, we want to determine how to draw a reliable conclusion about groups and events, and that can be groups in population or about the population in general, or like a sample in the population to see how those two might or may differ from each other, or if they're similar. This is also done by investigating data to make useful decisions and results, so that we can use them. So why is statistics important? So statistics, it can help us understand how to use the data, and by doing that, we can gain a better understanding of the world and the population or sample that we're using. We can make a better decision based on the data that we're using, and also we can make predictions about the future and maybe like what we want to do or what we should do based on the data. But what happens if we don't know the full story? So, for example, Many of you might have seen advertisements out there or commercials where they're trying to sell toothpaste. So they might say, oh, 5 out of 5 dentists recommend using this toothpaste. And then we always have to remember and also wonder about what was this compared to. So that could be, for example, if the company had compared using toothpaste versus not using toothpaste, and then of course the dentist would recommend a toothpaste, which was then 5 out of 5 dentists. Another example could be with, for example, if 4 out of 5 women prefer to wear high heels at work, then we also have to think about, okay, who was asked in this survey? And then it might be, for example, if all the people or all the women here were asked, but they all worked in a law firm where they always had to dress up and had like company policy. So, for example, they had to dress really nicely and really fancy clothes with high heels. Then that could be why that was it. Apart from that, like you can also, if you don't know the full story about, for example, the graphs. So if you see in the right corner here, if I can try to mark it here. So this one, for example. Um, so you can see on this, it says like there's a big chunk with yes, and then there's a small chunk with other answers than yes. And like with the title, should you avoid misleading data? Visualization just to support your argument. So this is an example of this. So for example, if you just visualize it and you don't think about proportion and stuff, for example, here is like 50% is saying yes, 50% is saying other than yes, but the yes part is just clearly bigger than the not yes part, and that might mislead from the bigger picture, which is actually is 50-50. Another example could be if you don't think about what you're comparing. So, for example, if you compare the American or US spending on science, space, and technology, and then correlate or compare it with suicide by hanging, strangulation, and suffocation, then you might see a correlation between those two, even though that they might not relate to each other. So that's why you always need to think about the full story and what is behind it. So now that we have covered some things that we probably should think about when we're doing statistics, we should also probably have some examples on the daily life and how it's used in daily life. So, for example, it can be used in weather forecast, and that would be when, for example, trying to predict what kind of weather we will have in the coming days based on previous weathers. So that could be like how are the clouds and is it raining or not, and so on. It could also be used in insurance, for example, when you have to predict, or the insurance company has to predict if you're quote unquote worth insuring, or what kind of risk the company will have to pay out money to the one who's insured. It is also used in elections, so that would be by sampling the population on who will win the election for the government, for example. So there, people would go out to ask the general population, so just the sample of those, what are you going to vote for in the next election? And then based on those answers, they would try to guess who the winning one would be. It could also be used in entertainment industry, and that would, for example, be Netflix when they're trying to predict what you might like to watch after the movie or series that you just watched. Or it could be targeting the marketing of products based on the predictions of who might want which kind of products. So, for example, maybe I don't know if you had young people, they would like, let's say, shooting games, for example. Then you would try to market it specifically for those people so that you can have a higher sale. If you talk specifically in video games, for example, you could have, for example, in competitive video game or competitive video game plays, just like in sport, you could look at like when they played wrong, then you could try to do some kind of statistics in, okay, what kind of plays was wrong here and what do you have to train. It could also be if you looked at, for example, in live streaming and video game streaming in general, what kind of trends are there, what kind of games will give more viewers and therefore also more money, and also the growth of those. And then finally, as I also used before with sports, you could try to find out, okay, this football player is shooting a lot of balls towards the goal and always misses at some part of the goal or from some specific place. Then that they could look at that and then try to specify what kind of training that football player should do or have. So now we're in the College of Pharmaceutical Science, so I think we should have some statistics in pharmaceutical field also. So how is that used in the pharmaceutical field? So for example, if you have clinical trials, you'll probably have that you have a new drug and you must then show a statistical effectiveness or significant or that the drug works on the different patients. Then you would have some groups and then compare those two with statistics. You could also have like quality control in product production of the medication. And seeing as you can't really test every single product because then it's kind of wasted, you need to like figure out statistically how many of the products should be tested for it to be relevant and be useful. And you could also use it for the monitoring of drugs, for the unwanted effects or the side effects. So how many side effects do I need to have before it's we think that it's probably the cause, like it's caused by the drug or associated with the drug. So that's all something that you can do in the pharmaceutical fields with statistics. So we have now talked about how statistics can be used in daily life, and we'll then have to move on to the next topic in statistics, which is data. So statistics, it works with a lot of data. You need a lot of data to be able to calculate some kind of statistics or predictions or conclusions. But what is data? So that's something we'll go through the next couple of slides. So what is data? So data is a collection of measurements and observations. And within the data, we have different data items, which are the variables in the data. So in other words, as I also wrote here, a data item is any characteristics or attribute which can be measured or counted. And some of the examples of these are height, country of birth, age, and sex. On the other hand, we also have different data units, and data units are then a single entity or a person, for example, and they're also referred to as records. And then the whole collection or the complete collection of the sets of observation, they're all called a dataset. And those are typically composed of several variables. And I'll show an example of that. So what I also covered in the how statistics is used in daily life, there was different ways that it could be used. For example, sport, elections and stuff. All of those, they require data from different sources because it's not always the same type of data that we're using. But what can these data sources then be, or what can these types of data be? So data can be almost anything they can think of. For example, it could be measurements about the weather. It could be types of DNA in the different people. It can be your money from the bank and how it grows over the year. So it can be practically almost anything you can think of. You can also have it, for example, if you look at Facebook or Twitter or any social media, those things can also be data. So within our dataset, we'll have different types of variables. And here is the classification of the variables. So the variable, it can be classified as either categorical or numerical. The categorical ones are the ones that we also call qualitative ones. And those are something that describes something. For the numerical ones, they're also called quantitative. And those are typically numbers. For the categorical ones, we can have nominal and we can have ordinal ones. The nominal variables, those are the ones that are mutually exclusive and unordered. So an example of that could be sex. You have male, female, for example, and you don't have anything that is better than the other. You can have blood groups like A and B and AB and O, and again, there's nothing that is better than the other. For the ordinal categories, though, those are exclusive and ordered, so there's an order to them. An example of those could be disease stages. So, for example, disease stage from mild to severe, and then there's clearly something that is better than the other because you don't want to be sick usually. For the numerical ones, so the quantitative ones, we have discrete and we have continuous variables. The discrete variables usually counts. So, for example, that could be amount of days sick per year. And the continuous ones, they are numbers that can take any value in a range. So that could be, for example, weight in kilo or height in centimeter. So those are the ways that we describe our variables. And as promised, I also have an example dataset here. So the whole table is the dataset in this instance. We would have usually variables at the top, so that's also data items. In this case, it's age, sex, and height. We also have the data units or the records, so those are the rows typically. And in this case, we have different people. We have person 1, person 2, 3, and 4. And then within, like in the middle, you will have the different observations. You would, for example, have numeric ones, you would have categorical ones. So, for example, in the first row, you would have person 1 is 20 years old, is a male, and is 160 centimeter height. And that's how you would write it in a data set then. So now we have covered the data, so what data is and how it looks and how we typically write it up in a table. So now we will go to the basics of descriptive statistics. So within the descriptive statistics, we can do some summaries. So all of these things is statistics which are used to describe our data. So some things that we typically use mean or the average of the data. So that's usually for numeric data. We can have a median, we can have a mode, and then we also have the minimum and maximum values, for example, in our dataset. And we have different ways to calculate those. So if we start out with the mean or the average, so the mean is the way to calculate it is that you sum all the values and then you divide it with the total number of all the values. So if we, for example, have a fictional course here, you have different grades that are given. You have 7, you have 8, you have 9, you have 10. It's a very clever class. You would then calculate the mean by first adding up all the numbers and then dividing it by the total number of all the values. So in this case, it will be 59 divided by 7. You calculate that, and you can do that by hand, and you can do that with a calculator. It doesn't matter. And then you'll get the number 8.43. So that's the average grade of the whole class, a very small class, but average grade. The median, though, it's a little bit different. So the median, instead of adding up all the numbers and then dividing it with the total amount, you would then just pick the middle value in the data when it's arranged in order. So, if, for example, if we again use the grades from before in the fictional course, the values would then order from low to high, so 7 to 10. Then you would have, or you would pick the middle number as the median. So it's very simple. You order them. You see, okay, there's 3 on this side, there's 3 on the other side. This is the number right in the middle. Then that's your median. And finally, we have the mode. The mode is not used as much as the other two, but the mode is basically the number which is most common in the set or in the column or the variable. So again, if we use the same example, we have the grades given in a fictional course. We want to find the mode. So we look at the different values of different grades that are given. And then typically what we do is we put it in a new table where we summarize, okay, this grade has been given this many times, and so on and so on. And then we can see, okay, grade A is it occurs 3 times, and therefore this is the most common value. It happens the most times, so that will be the mode then. So here is 8. So if we just quickly go back to the median, before one said that you just pick the middle number, so that will be the number which is in the middle of everything. That's very easy when it's uneven amount of numbers that you have. However, what would you then do if you have an even number? So in this case, we have also grades given in a fictional course. We have even number this time, so 6 students. So the way you find it for 6 students, or even numbers, is that instead of you just take the middle number, because there's no real middle number, because it's uneven number of students, you then take the 2 ones on each side of the middle. So for example, there's 6 here, so middle will be 3.5. So you would take number 3 and you would take number 4. You would summarize those two. So in this case, 8 plus 9, and then divide it by 2, and then you'll get 8.5, which is the median then in this case. So if we also go back to the notes, what happens if the same grade or 2 different grades have been given the same amount of times? So again, we go back to the modes, we go back to the grades, we have the fictional course here, and then you have the 8th grade has been given twice, the 9th grade has been given twice also. So then is it possible to have 2 different modes? And it is. So in this case, you'll have 8 and 9, both of these are the most common ones. Both of those have been given twice. So the modes here are both of those 2 numbers. So modes, you can have multiple of those. And then here we just summarize quickly what are the pros and cons of the different summaries, or the mean, median, and mode. So mean is most commonly used in our data, so you just pick the average. The mode is not that commonly used. I can't remember when we would use it actually. That's how infrequent it is used. And then the median is more used than mode, but a bit less than mean. And there are different advantages and disadvantages with using these. So with the mean, for example, the advantage of it is that it uses all the different data values in the variable, and then you can make a distribution, you can plot it and do stuff with it. One of the disadvantages you have with this is that if you have something, some values that are really far out from all the other ones, it will pull the average up or down depending on that value. For the median, however, the advantage of that is that if you do have those really like numbers that are really far out from everything else, it won't really matter as much because you basically just take the middle number. A disadvantage of that though is that you then would ignore most of the information because you're just taking the middle number. And then for the modes is usually you just ignore most of the information. You just pick the number which is occurring the most. And finally here we have variance and standard deviation also. So those two are also something that is very often used in statistics. So the variance is a measure of the variability of the data, and it is usually calculated by taking the average of the squared deviations from the mean. So this is a numerical value that shows how wide the individual figures in a set of data distribute themselves around the mean. And it also tells you the degree of the spread in your data set. So that means the more spread that you have in data, the larger the variance is in relation to the mean. And then a variance of 0. So if your variance is the same as 0, that means that all the data is the same, is identical. If we then take standard deviation, it's closely related to the variance. So the standard deviation is a measure of disbursement in the statistics. So it tells you how much your data is spread out. And specifically, it shows you how much your data is spread out around the mean or the average. And here I have also included the different formulas to calculate the variance and standard deviation. There is some difference in calculation between if you have it in the whole population versus if you're only calculating it for a small sample. But overall, the two different formulas for those two is very similar. And in addition to the variance and standard deviation, we can also calculate the standard error of the mean. So that's something that we usually denote with SEM. And that calculation is very simple. It's basically you take the standard deviation for either the population or the sample, and then you divide that number with the square root of the amount of patients or sample that you have. So this was also the final slide of this presentation. In our next lecture, we'll go through a bit more of the visualization of the data, as well as the different distributions that we can have. And we also have some assignments for specifically these first things that we've learned. So the mean, median, and also the variance and standard deviation, as well as the standard error of the mean. I will also upload the slides, this PowerPoint presentation, so that you can look through it yourself. Maybe you have missed something, then it's always good to be able to see it again. So I will see you in the next presentation. Thank you for listening.